Students, welcome to our mathematics second sem class. In previous classes, we discussed about conic sections. In that conic sections, we discussed parabola and ellipse. In the ellipse, we discussed the standard form of the ellipse and its parts. What is major axis and what is minor axis, and what is the eccentricity, what are foci, directrices, vertices. Like this we discussed. So today we will learn some more about the chapter ellipse, and we will discuss or we will do some problems on the ellipse. So today's class objectives: on completion of this period, you would be able to find the length of lattice rectum. We can say it is in the short form LLR, length of lattice rectum of the ellipse. Write other forms of the equation of the ellipse. Find sum of the focal distances of the ellipse. To find the length of lattice rectum, in short form we say LLR, capital letters are LLR. First L is length of, second L is lattice, R is rectum. So length of lattice rectum. First we have to know what is length of lattice rectum. Length of lattice rectum is a line, and it is passing through the focus and perpendicular to the axis of the ellipse. Here we are discussing about ellipse. In parabola also same, passing through the focus and perpendicular to the axis. So that is lattice rectum. Length means the line lattice rectum where it cuts the ellipse. And here, like parabola, in ellipse also it cuts two places, in upper part and in lower part, that is L dash we say. So that L to L dash is called the length of lattice rectum, and this is passing through the focus and perpendicular to the axis of the ellipse. The same way in parabola also same condition. So let us see the diagram. Here two lattice rectums are taken because two foci are here, S and S1, and L1 is indicated in blue ink. Another line also S1 at S1. The length of lattice rectum is indicated in blue ink. So both the lengths are same because it is symmetric, and the foci are the same distances from center either sides. So the diagram or ellipse is also symmetric with both the axes, and then length of lattice rectums are same. So if you find one lattice rectum, it is applicable to another side lattice rectum also same. So here the blue line or blue intercepted part is indicated length of lattice rectum, and we can see it is passing through the focus and perpendicular to the axis. Here axis is given in a brown color or red color, we can say, or maroon color. So the lattice rectum cuts the ellipse at 2 points. One is L at upper point and in the lower side L1. So if we know the point L, then we know the distance between S to L, and same distance covers S to L1 also. Only direction is change. See the diagram, and chord through the focus perpendicular to the major axis is called lattice rectum. So in the circle also, if the intercept part or intercept line is, we say, chord. Here also L1 is, we can say, it is one of the chord, and it is perpendicular to the major axis and also passing through the focus. So that chord is called lattice rectum. So there are so many chords in the ellipse, but which is passing through the point focus or fixed point, and it should be perpendicular, because there are so many we can form or we can draw intercepts through focus in any angle we can draw, but that is not a point. Another condition is it is perpendicular, then only it is called lattice rectum. So here you observe the diagram, and the lattice rectum LL1 is indicated in blue ink. It is passing through the focus and it is perpendicular to major axis. Here A1 is that line is called major axis, which is given in a brown color or maroon color or light red. That is L1 in the above figure, we can say lattice rectum, and that particular distance we can say length of lattice rectum. Let LS equals to Y1, then LS equals to L1S, as the curve is symmetric about the coordinate axis. You can see the diagram also, it is symmetric. So, and it is look like S is the middle point of LL1, and it is same distance because it is symmetric also. So we can take directly LS equals to SL1 or L1S. Same distance will be there because the curve is or ellipse is symmetric about coordinate axis, or we can say its axis. So L is, we can say, the point L, A comma Y1, because L is a point which is collinear to S, L1, and S we know A comma 0. So from center, S is the distance with A. In the same way, L is also same distance. So A comma, the height we don't know, That's why we are taken y1. The same way L1, that means opposite direction of focus, or L. So L is in positive direction and L1 is in negative direction, or L is upward direction and L1 is downward direction to the S. So L1 point we can say A comma minus y1, because L is a first quadrant. So in first quadrant x and y are positives, that is abscissa and ordinates are positive. When comes to fourth quadrant for L1, here x is, that is abscissa is positive but ordinate is negative. So that's why L1 we can take A comma, we took L1 equals to A comma minus y1, same height from S, or we can say the center on y-axis. So the equation of the ellipse is based on the diagram, we can say it is a first form, and we know because yesterday we discussed the first form of the ellipse, that is x square by a square plus y square by b square equals to 1. Here a is the length from center to vertex, or distance we can say, and b is the length from center to vertex on minor axis. So here a is greater than b, and in place of x square we can, in place of x we are taking point L and a comma y1. In place of x and y we are substituting the point L, because L is a point on the ellipse, so every point it satisfies its equation. So in place of x we can take a, so x square means a whole square, that means a square into e square, plus in place of y we can take y1 whole square, that is y1 square equals to 1. So y1 square by b square equals to 1 minus e square. Y1 square equals to b square into 1 minus e square, that equals to b square here we, here the step is taken, in place of 1 minus e square, b square by a square is taken, but it is looking like wrongly typed, but if we substitute e square value, then we can say we say it is not wrongly typed, it is typed properly, because e square equals to 1 minus b square by a square. So in place of e square, here the step is written directly, that's why I confused, but now I knew that it is taken directly, so that it is a right step, and it is not a typed wrongly, but it is a direct step, because e square equals to, we have the formula 1 minus b square by a square. So if we substitute minus 1 minus into minus plus b square by a square, so 1 minus 1 get cancelled, so remains b square by a square. So he substituted in place of e square 1 minus b square by a square, and the before e square we have negative sign and multiplied, then after simplify or after getting 1 cancelled, the remaining part is b square by a square. So this is the right typed letters, and it is not a mistaken, but it is taken a direct step. Okay, now b square into b square, b power 4 by a square. Now if the left side we have y1 square, so the power 2 if goes to right side, it's become a root. So under root of b power 4 by a square means plus or minus b square by a. So this is the y1 value. So y1 means we already know the height of the L, that is from x-axis to, or we can say height of the from center to on y-axis or up to L. So a comma b square by a, that is the one L, and L1 is also same a comma minus b square by a. So SL equals to y1, that equals to b square by a. Length of lattice rectum equals to LL1, that equals to 2 into SL, and that equals to 2 into b square by a. So finally we got length of lattice rectum equals to 2 into b square by a, because half of the length we got b square by a, and another downward also same length, so b square by a total 2b square by a. So equation of lattice recta or latera recta we can call, or we can say, are x equals to plus or minus ae. This we know because the focus is located on the axis x, and the distance is x equals to a, or the distance from origin to focus is a. So the lattice rectum is going through the focus. So the location or equation of the line of latera recta is x equals to a. Two latera recta, because two focus or foci are there. So another latera recta equation is only direction change. So that's why if we said for both latera recta, then we say x equals to plus or minus a. So plus a is for positive side focus latera recta and minus a is the equation for negative side lateral recta. Equation of the ellipse with the center at C, H comma K, and major axis parallel to X axis is, see here, the center is 0 comma 0 and axis is coordinate axis. Then we know the equation is of the ellipse is x square by a square plus y square by b square equals to 1. Here the center is not 0 0, it is h comma k, that is center is moved from the origin, and axis also not a coordinate axis but it is parallel to x-axis, the major axis is, and similarly minor axis is also parallel to y-axis. So here we say origin is shifted to h comma k, so that's why the equation is also altered or changed. Then the equation is, we say this is a third form because first two forms are the centers, origin or center is 0 comma 0. In the third form center is changing h comma k, so equation also changes. The equation of the ellipse is x minus h whole square plus y minus k whole square equals to 1. So in place of x we took x minus h whole square. Here bracket is not printed or not showing, but we have to kept the x minus h in a bracket and y minus k also. See, the diagram is like in the figure. Here the pink line is axis of the ellipse and it is parallel to x-axis, and minor axis is in color green and it is parallel to y-axis. So the ellipse center is h comma k. Then the equation is x minus h whole square plus y minus k whole square by b square equals to 1. So little changed. In the first form only x square we have. Now this is called third form. In place of x we took x minus h, and in place of y we took y minus k. For the above ellipse, the center at C h comma k, major axis parallel to x-axis, vertices at A, h plus or minus a comma k, and foci at, here plus or minus means two vertices are taken. One vertices is right side of the center and another vertex is left side of the center. So both, if we want to express, then we can say h plus or minus a comma k. So h plus a is right side vertex to this center, and h minus a comma k is a point which is the left side of the center. In the similarly foci, we can say h plus r minus ae comma k. So if we take one focus point, if it is in right side, we say h plus ae comma k. In the same way, if we say the left side focus, which is from center point, then we say for another focus is h minus ae comma k. So for positive side, h plus ae comma k. For negative side, h minus ae comma k. Equation of directrices are x equals to h plus r minus a by e. Here also two equations expressed in a single way or in a single line using plus or minus. If we say the positive direction for directrix, equation is x equals to h plus a by e. And if we want to left side directrix equation from center, say the equation of the directrix is x equals to h minus a by e. Equations of lateral recta are x equals to h plus r minus ae. So same here, lateral recta also we have two. To express in a single way, we say x equals to h plus r minus ae. So one lattice rectum is right side of the center and another one is left side of the center. If we say right side of the center for lattice rectum equation, then the equation is x equals to h plus ae. Similarly, if you say the left side lattice rectum from the center, which is passing through the focus, then the equation of lattice rectum we can say x equals to h minus ae. Equation of major axis. See here, equation of major axis is y equals to k, because center is h comma k. So k indicates its position or height. So equation of major axis is y equals to k, and equation of minor axis is x equals to h. So major is y equals to k and minor is x equals to h. So major axis is y equals to k and minor axis is x equals to h. Length of lattice rectum we already discussed just now, that is 2b square by a, or 2 into b square by a. Equation of the ellipse with center at c h comma k and major axis parallel to y axis is in bracket given a is greater than b. So here major axis parallel to y axis means it is in the form of second form, but the difference is in the second form center is 0 comma 0, here center is h comma k. The diagram is in the vertical position. In third form it is a horizontal, now it is become a vertical. So here axes are changed, so equation is also little bit changed in the same way. Like first to second yesterday we discussed, in the same way now third to fourth, or it is like a second form. See the here the vertical ellipse we taken, because here now the major axis is parallel to y axis and now the minor axis is parallel to x axis. So axes are interchanged, so the equation is also like looks like interchanged. In place of x minus h we taken y minus k. In place of y minus k we took or we taken x minus h. See here the equation is, we can say this is a fourth form. In ellipse here we discussed 4 forms. 2 forms are with center 0 comma 0. In the 2 forms, one is major axis is axis as a x axis, and another one is major axis is axis of y axis along y axis, and here third form is parallel to x axis and fourth form is parallel to y axis. So equation of the fourth form is y minus k whole square by a square plus x minus h whole square by b square equals to 1. Here a is greater than b. So in the second form center, if it is 0, we say y square by a square plus x square by b square equals to 1. And come to the fourth form, the center is at h comma k instead of 0 comma 0, so that's why little bit changed. Y minus k whole square, here bracket is missed, so we should kept in the bracket. Y minus k should be kept in the bracket, and same x minus h also. So equation is y minus k whole square by a square plus x minus h whole square by b square equals to 1. For the above ellipse, the center is at h comma k. Same like third form. Major axis is parallel to y axis. In the third form, major axis is parallel to x axis. That is the main difference. Vertices at a h comma k plus or minus a. Now we changes the ordinates and we prefer the ordinates. So From third to fourth, the preference is changes to abscissa to ordinates. So that is the difference we have to observe here. Foci at S, H comma K plus or minus AE. Equations of directrices are y equal to K plus or minus A by E. See, vertices or focus or directrices all are changes according to the y-axis or ordinates, because these are all on y-axis. Equation of lateral recta or y equals to K plus or minus A. You already knew y plus or minus. The plus is taken, that is upward side. If minus is taken, that is downward side from center. So one is positive direction and another downward is negative direction. Equation of major axis is x equals to h, because it is passing through the x-axis at h distance. That's why equation is, we can say, x equals to h for major axis. And minor axis, y equals to k. Length of lattice rectum is equals to 2b square by a. Equation of the ellipse with one focus at x1 comma y1, the corresponding directrix as ax plus by plus c equals to 0, and eccentricity is given by, so here left side the brackets are missed, you have to keep it in a bracket. So the equation is when focus and directrix and eccentricity is given, then we'll say x minus x1 whole square plus y minus y1 whole square equals to a square into ax plus by plus c by under root a square plus b square whole square. Here you have to keep x minus x1 in bracket and y minus y1 also in bracket, are kept in a bracket. So if we observe to parabola and ellipse, the difference is only e square. In parabola, we need not to write e square because eccentricity is 1. 1 square means it is 1. 1 into something, something. In the ellipse, it is not a 1. It is less than 1 and we don't know how much it is. That's why we are taken e square extra. Compared to parabola, only e square is extra product here. So this equation is also same as a parabola. Based on condition sp by pm equals to e, and the pm, if it took right side, sp equals to e into pm, and squaring on both sides, we get this equation. And this equation is also same for hyperbola. The sum of focal distances of any point on the ellipse is equal to its length of major axis, that is constant. The sum of focal distances of any point on the ellipse is equal to its length of major axis. See here, SP is indicated in a green color and S1P also indicated in green color. If we added both, we get its length is equal to major axis, that is 2a. Let P is a point x comma y on the ellipse. C be the center of ellipse. S signed S1 be the foci of the ellipse. ZM and Z1M1 be the directrices of the ellipse. A1, B1 be the vertices on the major and minor axis respectively. PM comma PM1 be the perpendicular distance on ZM and Z1M1 respectively. By the definition of conic, we know SP by PM equals to E and SP equals to E into PM. Let it be 1. Similarly, S1P by PM1 equals to E and S1P equals to E into PM1. Consider it as a equation number 2. From 1 and 2, left side terms, if you add it is SP plus S1P, and add right side terms E into PM plus E into PM1, then E is taken common, PM plus PM1, that is MM1, then E equals to 2A by E, distance between directrices. Then equals to E cancel 2A. Therefore, SP plus S1P equals to 2A. That is equals to length of major axis. So here which questions are also given. Let us see. A length of lattice rectum of an ellipse is A 2A square by B, B 2B square by A, C A square by B. So we already proved in this class it is 2B square by A. So option is B. So here generally A is greater than B. Sum of the focal distances of an ellipse is. Just now we got that. So let us see the options. A 2A and B 2B and C none. Sum of the focal distances of an ellipse is, so that is 2A. Summary. In this session, you have learnt for an ellipse, a length of lattice rectum is 2B square by A. Center C is the midpoint of the foci S1. Vertices A1. directrices ZZ1. So based on diagram also we can say C is the center for focus, vertices and directrices. And length of lattice rectum is 2b square by a. And lattice rectum is passing through the focus and perpendicular to the axis of the ellipse. So in the ellipse we have two focus points and two vertices on major axis and another two vertices on minor axis and two directrices or two directrix, one is left and another one is right side. So two directrices are in ellipse. So, and one more thing we learned, the sum of the focal distances is equals to length of its major axis. So this is the ellipse forms, parts and equations, and you see the example problems and try to do exercise problems from textbook. So here generally we have to know we have to find how to find given equations. From given equations its parts. He gives the equation and asks the focus or center or vertex or lattice rectum, whatever he asks the parts we have to find. So if you understand the concept you can easily do. So try to do exercise problems. If you have any doubts you can ask me, or you can call me, or you can message me on WhatsApp also, so that I will clarify your doubts and do homework problems, and remaining we discuss in next class. Thank you.